Okay, let's talk about what it means to be congruent and what it means to be similar. Congruent we've already talked about a lot, but this statement says that triangle ABC is congruent to triangle DEF, right? Take a look at these two. What does it mean for two figures to be congruent, in this case triangles? Again, to be congruent, the shapes are exactly the same. They're the same shape. They might have been rotated or reflected or moved, right? Those are three rigid transformations, but it's the exact same shape, meaning the exact same corresponding sides, meaning congruent corresponding sides, and congruent corresponding angles. So in this case, if it says that triangle ABC is congruent to DEF, angle A and angle D are the same. These angles right here, congruent, same measurement. Angle B, angle D, the same. They're the corresponding ones. Angle C, angle F, the same. And side lengths, AB, that guy, is exactly the same length as DE. BC is congruent to EF, same length. And that guy is congruent to that guy. The shapes have the exact same sides, and congruent angles. They'd have the exact same perimeter, they'd have the same area, and so on. Similar shapes, this is the symbol for similar. Triangle MNP is similar to triangle RST. They have congruent angles, congruent corresponding angles. Congruent corresponding angles, but they have proportional side lengths. They are not the same size. They don't have the same perimeter. They don't have the same area, but their side lengths are in proportion. However, the angles are congruent, just like over here. So they're the same version of a shape. So they're still a triangle, and there's still a particular type of triangle. They're just a bigger or smaller version of it. Proportional side lengths, it'll turn out that it can be enlarged or it can be reduced. If you started with this small one, you could enlarge it and get this bigger version. Or if you start with the bigger version, you could reduce it to get this one. Again, an example of something like this, I could make this 3, 5, 7. And then if this was going to be a similar figure, I could make maybe the scale factor 2, which would make that 10, 6, and 14. Those figures are now similar, assuming that since it's given, these angles are the same. So this angle and that angle are the same. That angle and that angle are the same, congruent, and those angles. Okay, similar figures, corresponding angles are congruent, side lengths are in proportion. All three pairs, in case of a triangle, need to be proportional. Twice as big, twice as big, twice as big. If any one wasn't that same ratio, then they wouldn't be similar. Congruent triangles are exactly the same triangle. Okay, how did we prove? Okay, proofs. Over here, how did we prove things were congruent? Well, we had side, side, side as a proof. If you can show me that the three sides of a triangle are congruent, then the triangles themselves were congruent. We had angle, side, angle. We had side, angle, side. We had angle, angle, side. And we had hypotenuse, leg. All 5 of those in review were proofs that if you could show me that 2 separate triangles had side, side, side congruency, then the 2 triangles were congruent. And all of these also, because they proved the 2 triangles were congruent, these proved that the triangles were congruent. But if the triangles were congruent, then the corresponding parts of congruent triangles were congruent, meaning that's the definition of what it means to be congruent. Okay, over here, similarity, We talked about in class that we have angle-angle similarity, right? The triangle sum theorem really says that if you have two triangles, and again, this is just for triangles, if you have angle-angle, that really, the triangle sum theorem says you have angle-angle-angle. And angle-angle-angle means the corresponding angles are congruent, thus the side lengths will be proportional. That proves similarity between two triangles. Okay? We also said in class that if you can show side, 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 meaning all three pairs of corresponding sides are proportional, side, side, side are proportional, then you know the triangles are similar. And actually, you can do side, angle, side. So in that one, it was showing two sides are proportional and the included angle is congruent. Okay, so that one was a little tricky in that you had something like this, okay, and you knew that this was 4, and you knew that was 8, and you knew this was 6, and you knew that was 12, and you knew that was 40 degrees, and that was 40 degrees. That was enough to know that those two triangles were similar. These were a 2-to-1 ratio. That's a 2-to-1 ratio, and the included angle, side, was congruent. That was enough to know for sure that these two things were actually similar. Again, angle, 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 that picture is pretty easy. Hopefully this one makes sense. If you had something like this, and you had like the bigger version of that, that if you knew that this was 110, and that guy was 110, and this guy was 30, and that guy was 30, then the triangle sum theorem really tells us that even if, just forget about this whole similarity thing, if that's 110 and that's 30, this angle down here has to be 40, because we know there's 180 degrees in a triangle, which means if that's 30 and that's 110, well, that's got to be 40 degrees. So really, if two angles are the same, their third angle has to be the same. And if you have angle, 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 then you have two triangles are similar. And again, at that point, you know these two triangles are similar. So if you had, a pair of sides, you could actually figure out the scale factor, and then all the sides would have that same scale factor. Again, we spent a lot of time proving triangles are congruent, and now we're going to spend some time proving that triangles are similar. If the triangles are similar, if you can prove they're similar, you know then that all the corresponding angles are congruent, and you know that all the side lengths have the same proportion. They're all twice as big, 2.5 times as big. They're all 1/3 as big if it's a reduction. Okay? So there was a big difference between proving things are similar and proving things are congruent. Again, proving things are similar is you can just compare all of the side lengths. Again, it doesn't have to be for triangles. These are specific to triangles, just like these were. But again, you can take two hexagons. You can take two trapezoids. And again, if you know the trapezoids, all their side lengths, you can tell me whether or not they're similar as well. The scale factor can be something bigger and make it big, or you can start here and make it small, meaning reduce it. Okay? Similarity statements are like this right here. And again, the order does actually matter. So in this case, I'm going from the 1 to 2 to the 3, 1 to 2 to 3, and they match up, because just like over here in congruent things, angle A was congruent to angle D, angle M and angle R are the same. Side length MN is proportional to side length RS in the exact same way. So we have to be able to write similarity statements just like we did congruent statements. Okay, hopefully this helps you kind of compare these things. And again, this is really what, 6.3, three part A, part B, maybe a little bit of 6.4 of using and proving what it means for two triangles to be similar.